Hey, Mr. Holtz, this is my test series video project. So question number 1. Let R be the region enclosed by the graphs g of x equals -2 plus 3 cosine pi over 2x, and h of x equals 6 minus 2 times x minus 1 squared. The y-axis and the vertical line x equals 2, as shown below. The region R is the base of the solid. For the solid at each x, the cross-section perpendicular to the x-axis has an area of a of x equals 1 over 3x plus 1, and then asks us to find the volume of the solid. So first I drew my picture with labeled slice. My labeled slice is right here, and the top coordinate is x1, y1, and the bottom is x1, y2. And then I drew an arrow and said that the area involving this labeled slice is 1 over 3x plus 1 because we learned that in this part of the problem. And then I put my equation, which is dv equals a of x times change in x. And then I found the integral of each side, and then that simplified to v equals the integral from 0 to 2, because right here is 0 and right here is 2. That's the whole region. And then of 1 over 3x plus 1, because that's a of x, and then you change the change in x to differential dx, because you find the integral of each side. And then I found the antiderivative to be 1 over 3 ln 3x plus 1, and from 0 to 2. And then I use FTIC part 2 to simplify that down, and I got an answer of ln 7 over 3 units cubed. Question 2, it says find the volume of the region bounded by y equals x squared minus 2x minus 8 and y equals 4x minus x squared, rotated about the line y equals 5. So first I drew my picture with labeled slice. The lower coordinate is x1, y1, the upper one is x1, y2. And then I have a third coordinate for this one, which is on the axis of rotation, which is x1 and 5. So first I set these two equations equally to each other. It's in order to find the limits of integration, and I solved that and found the limits of integration to be x equals -1 and x equals 4, which are these two of those 2 points. And then I put the equation dv equals area of large slice, which is this from which is y1 to 5, minus small slice, which is 5 to y2, and then change in x. So I found the integral of each side, and then I got volume equals the integral from -1 to 4 of pi times 5 minus y1, which is the big slice, squared, because that's the radius, r squared, minus pi times 5 minus y2 squared. 5 minus y2 is the small slice. And then dx. And then I took out the pi in the next step and then plugged in y1 and y2. And then I simplified that down to here. And this is the final one where I took the antiderivative. So I took the antiderivative of this one and got -2 over 5 x to the 5th plus 3x to the 4th minus 4 over 3x cubed minus 6x squared plus 194x. And then that's from -1 to 4. I used FTIC part 2 to plug in the values of -1 and 4 and simplified that. And my final answer was 3,445 over 3 pi units cubed. Question 3, it says find the volume of the solid generated by revolving the region bounded by y equals the square root of e to the negative square root of x over square root of x. X equals 0, y equals 0, and x equals 4, and then we're revolving it around the x-axis. So first I drew a picture with labeled slice. So I drew like around the same picture as this, but I also drew the x equals 4 because that's what it's bounded by. I drew the labeled slice of x1, 0 for this coordinate, and x1, y1 for this coordinate. And then I put the volume equation, which is dv equals pi r squared, change in x. And I found the integral of each side. And I got v equals pi times the integral of from 0 to 4, because it starts at x equals 0 and ends at x equals 4, of the r squared, and the r squared is the y, because it's y1 minus 0, so it's the square root of e to the negative root x over root x squared dx. I put the pi out because you can do that if you integrate each side. And then I squared that and got this value. So then I figured out that you're supposed to do u sub for this problem. So I made u equal the square root of x, and then du equals 1 over 2 times the square root of x dx. And then I plugged those numbers in and got pi over 2 because I brought this 2 out of the integral to make pi over 2 instead of pi, and times the integral of 0 to 4 from 0 to 4 of e to the negative u du. And then I found the antiderivative of that to be negative e to the negative root x from 0 to 4. I've changed from u to x's because that's what you're supposed to do in order to find it. And then I did FTIC part 2 and simplified that down, and the final answer I got for this problem was pi e to e squared minus pi over 2e squared units cubed. Number 4. So number 4 asks you to find the limit as x approaches 0 from the right of sine x to the x power. So I wrote that down, and then first I found ln of this limit. So then I can use the property and bring down the x that we learned back in the pre-calc. And then after that, I put ln sine of x divided by 1 over x, because you can bring this x to the denominator. And then after plugging in 0, I realized that it's infinity over infinity. And then I use L'Hopital's rule to find the derivative of the numerator and the denominator, because it's infinity over infinity. And I found those derivatives to be 1 over sine x times cosine x divided by negative 1 over x squared. And I changed that to be cotangent x, because that's what cosine x over sine x simplifies to. And then I took the negative out of the denominator. In the next step, I switched x squared to the numerator, and I made the denominator tangent x, because cotangent is 1 over tangent x. And then I once again plugged in 0 for this limit, and I got 0 over 0. So I also used L'Hopital's rule once again, and found the derivative of the numerator to be 2x, and derivative of the denominator to be secant squared x. And finally, I can plug in the values, and I get an answer of 0. But that's not the end, because remember when we took the ln in the beginning, that means we have to put e to the power of this. So e to the 0, and then that's the final answer, which ends up to be 1. Okay, so number 5, write the equation for the normal probability density function in standard simplified form using the data below. So the data is 6, 4, 7, 8, and 5. I put those in numerical order because it's easier for me. So the first step, I find mu, or the mean of this data set. So I add them all up and divide by 5. That ends up to be 6. The second step, I do all these numbers minus the mean for each number. So I got -2, -1, 0, 1, and 2. Third step, I squared every number from step 2 and got 4, 1, 0, 1, and 4. And the fourth step, I found the mean of the numbers from the third step, so add them all up and divide by 5, and I got 2. Then the fifth step, I got sigma, or the standard deviation, to be √2. And then after that, I found the equation for the normal probability density function is f of x over sigma times √2 pi times e to the negative x minus mu squared divided by 2 sigma squared. That was from our notes. And then I plugged in √2 and then 6 for the sigma and the mu. And I simplified that down to be f of x equals 2 root pi, and then e to the negative x minus 6 squared divided by 4. So that's the normal probability density function. And then question 6, what percentage of data from number 5 are between 2 and 3 standard deviations greater than the mean? So first I drew the bell curve, the standard bell curve, and the mean is 6 at the top, and then as one standard deviation, 2 standard deviations, 3 go down, the percentage gets lower. So it's 6 plus √2 here for 1, because the √2 is the standard deviation we found from the previous problem. And then 2 standard deviations is 6 plus 2 √2, and 3 is 6 plus 3 √3. And then I found out that 2 standard deviations, 6 plus 2 √2, is greater than 8. and that's the largest number in the data set. And then also, if that's greater, the three standard deviations is also going to be greater than 8. So if the 2 and 3 standard deviations are greater than the mean, are both greater than the largest number in the data set, that means that 0% of the data from the previous problem, number 5, is between 2 and 3 standard deviations greater than the mean. Number 6. Bucket weighing 200 newtons empty is lifted to the top of a 50-foot ladder by a rope weighing 0.8 newton per feet. The bucket is filled with water but has a constant leak, so when it reaches to the top, there is no water remaining in the bucket. If the water is initially 100 newtons, what is the work done by lifting the water, rope, and bucket to the top of the ladder? So first I found the work done by lifting the bucket alone. So I used the work equals force of the bucket alone, which is 200 newtons, times distance, which is 50 feet. And I got the work by lifting the bucket alone to be 10,000 newton feet. And then after that, I found the work done by lifting the water alone. And so at 0 feet, there's 100 newtons of water, because initially there's 100, and then 50 feet, because the ladder is 50 feet tall. I found the slope of this to be negative 100 over 50, which is negative 2. I plugged that into the slope-intercept equation, which is negative mx plus b. So I plugged in the slope and the y-intercept, which is 0, 100, and got negative 2x plus 100, or 100 minus 2x. And then I put that into an integral from 0 to 50, because it's initially at 0 feet and you're raising it up to 50 feet. So it's the integral from 0 to 50 of 100 minus 2x dx. I found the antiderivative of that to be 100x minus x squared from 0 to 50. I used FTIC part 2 to plug in 0 and 50, and I got 2,500 newton feet for lifting the water alone. After that, I found the work done for lifting the rope alone. So at 0 feet, the rope initially weighs 40 newtons. I got that by doing 0.8 newton feet times 50 feet, which turns out to be 40. And then the same thing as before, it's a 50-foot ladder, so it's 50 feet for the other coordinate. And then the slope of that is negative 40 over 50, which is negative 4 over 5. So I plugged that into the slope-intercept equation, get negative 4 over 5x plus 40. 40 is the y-intercept. Or I simplified it down to 4 over 5 times 50 minus x, because then I could bring the 4 over 5 out of the integral in the next step. So the next step, it's 4 over 5 times the integral from 0 to 50, because 0 and 50 feet, times 50 minus x dx. I find the antiderivative of this to be 50x minus a half x squared, and then from 0 to 50 like before. And then use FTIC part 2 to plug in 50 and 0, and I get the final answer after multiplying the 4 over 5 to be 1,000 newton feet. So after that, we're not done yet. We have to add up all three of these numbers to find the total work done, and the total work done is 13,500 newton feet. Question 8. Find the length of the curve below over the specified interval. And the function is f of x equals the integral from 2 to x of the square root of t cubed minus 1 dt, and then it's from 4 to 6. So first I use the fundamental theorem part 1 to find the derivative of this function. I found that to be the square root of x cubed minus 1. We're going to need that for the next step, because the next step we find the length function, which is the integral from a to b, lower and upper, of the square root of 1 plus the derivative of the function squared at dx. So I did that, I wrote that down, and then I plugged in 4, 6, because we got that from the original problem. The lower limit integration is 4, the upper is 6. And then I plugged in the derivative of the function from right there when we did FTIC part 1. I plugged that in, I simplified it down to from the integral of 4 to 6 of x to the 3 halves dx. I found the antiderivative of that to be 2 over 5x to the 5 halves. And then from 4 to 6 like before. And then lastly, I did this the FTIC part 2 to simplify it down, and I got the final length of the curve to be 72 root 6 minus 64 over 5 units. And then finally, go blue, of course.